All right, so let's move on to question 2 for chapter 6. Question 2 says a 90 gram bread on a 60 centimeter long string is swung in a vertical circle about a point 200 centimeters above the floor. The tension in the string when the bead is at the very bottom of the a bead, not of bread, man. This is dumb. I'm sorry. Bread. I'm hungry. I'm thinking about food. That's what I'm thinking about right now. Bead. Bead is at the very bottom of the circle is 2.2 newtons. A very sharp knife is suddenly inserted, as shown in figure 6.3. This figure. To cut the string directly below the point of support. How far to the right of the center of the circle does the ball hit the floor? All right. So the ball is getting circular motion. The knife. Circular motion. The ball is going in a circular motion. Yada yada. The knife cuts right here on the string, and we gotta figure out how far to the right the ball travels. So again, we're gonna use a centripetal force with the tension and mass. So we're gonna have tension equals weight, mg, plus centripetal force over radius. So it's given that our tension is 2.2. Basically, all we're doing is plugging in 2.2 equals 0.09, and our gravity is 9.8, plus our mass, once again, it's 0.09 v squared, we don't have, over 0.6. So we have 2.2 minus 0.82 equals 0.09 v squared over 0.6. Now this 0.882 comes from the multiplication of these two and moving it towards the left side. That's why we have a negative. So when you do this subtraction, you get 1.318 equals again 0.09 v squared over 0.6. When you multiply, because now we're solving for v squared. So to solve for v squared, we have to multiply 0.6 on both sides to cancel this 0.6. So 0.06 multiply, 0.6 multiplication, these two cancels out. So you end up with, okay, so you get v squared equals 8.79. Why 8.79? Because once you multiply 0.6, 1.38, you're left off with this 0.09. So to just isolate v squared, we must divide. So we're dividing the product of this number by 0.9. That's why it's going to give us 8.79. So when we get the square root, we get 2.96. So the initial height, now we're going to calculate for the initial height. Initial height. Which is our y equals 200 minus 60 equals 140 centimeters. Converted to meters is 1.4. So our initial in the y direction is 2.96 meters per second, and our y, it's 0. So now let's use the formula for y, VOY times t plus 0.5 gravity times square. So just plug in your values. 1.4 equals 0. This cancels out. Plus 0, 4 point, when you multiply all of that, you get 4.9 times square. Oh, when you multiply 0.5 times 10.8, you get 4.9. And then just to isolate t, we get 0.5, just to make it quicker, we get 0.5345 seconds. So this value comes from dividing 1.4 by 4.9 and then getting the square root of t. And that's the value for that when we find the square root. So we have our t, we have our v. So to find our x, okay, so to find our x, we're gonna use this formula. We're gonna use x equals v initial of x times t. So we have equals 2.96 times 0.5345, which equals 1.58 meters, and to just convert it to centimeters is 158 centimeters. So that's the answer, 158 centimeters. So since we don't have the 158, we're gonna round up to the 160.